Discrete probability distributions. Our objective, we're simply going to identify discrete probability distributions. Is it or is it not a discrete probability distribution? What do we know coming in that we're going to use here? We know what a random variable is, a numerical measure of the outcome of a probability experiment whose value is determined by chance. We know what a discrete random variable is, a random variable that has either a finite number or a countable number or values. And we know the rules of probabilities. The probability of any event E occurring, which we write as the probability of E, must be greater than or equal to 0 and less than or equal to 1. Mathematically, P of E is between 0 and 1 inclusive. And we know that the sum of the probabilities of all outcomes must equal 1. Let's apply that here, and we'll see that this is not overly complicated, I don't think. The probability distribution of a discrete random variable x provides the possible values of the random variable and their corresponding probabilities in the form of a table. We have an example below, a graph, which will be our next objective, or a formula, which will be a later objective we're doing in the form of a table today. And what are the rules? It is a discrete probability distribution if P of x denotes the probability of random variable x equals x, then the sum of P of x is 1, and all the P of x's individually are between 0 and 1 inclusive. Very, very similar, if not identical, to what we have right up here. Okay, this is the rules for it to be a discrete probability distribution. If these two pieces if one or both of these two pieces is not met, it is not a discrete probability distribution. Let's take a look at an example. Do some basketball. Suppose we ask a basketball player to shoot to shoot 3 free throws. Let the random variable x represent the number of shots made. So x equals 0. This basketball player made none of the 3 free throws. 1 free throw made, 2 free throws made, or 3 free throws made. Don't say that 3 times fast. The table shows a probability distribution. So back to here, we're doing form of a table right here for the random variable x, number of shots made. And we're told here that 0 shots made, there's a probability of 0.01. 1 shot made, the probability is 0.10, which is 10%. 2 shots made, 0.38, 38%. And in this case, all 3 shots made take place 0.51. A probability is 0.51, which we know is 51%, if we want to read it as a percentage. Is this, we're just identifying it, is this a discrete probability distribution? Well, here are 2 rules. Is the sum of all the probabilities equal to 1? Okay, so number 1, the sum of all probabilities equals 1. Well, if I add up these 4 numbers, I get 1.0. You can add them up yourself quickly if you'd like to. Excuse me. So the answer is check. That's true. Okay, number 2. Are the individual probabilities between 0 and 1 inclusive? So, do we have the individual probabilities? Are they between 0 and 1 inclusive? Well, this one's between 0 and 1. This one's between 0 and 1. This one's between 0 and 1. And this one is between 0 and 1. So check. We have met the 2 criteria for it to be a discrete probability distribution. So is this? The answer is yes, it is a discrete probability distribution. We're going to take a look at this in a graph. In a graph. in our next video.